actually benefit anyone. It's just another paper. I write or my student write, and then somebody, the reviewers only read, and then it's forgotten. So what's the difference I'm making to the society? So then I started thinking this and started working on something which will actually make difference to people's life. And actually, the story starts that in 2018, I was in Germany to complete my Humboldt stay in the summer. And then my parents, I invited them, they joined from Kolkata, and they were in Germany also for 1 month with us. And I wanted to show them around. And my father cannot walk very well. So he was very worried that he cannot see anything, but he loves to travel. So I bought a wheelchair, a manual wheelchair, okay, the one you push through. And I pushed him, through different cities, different countries. And I walked a total of 165 kilometers on foot to show him different parts of Europe. And then I realized that it's not easy for people on wheelchair to see, go to unfamiliar surroundings. Maybe in your neighborhood, in your locality, you can move. But when you go to new places, then it's not easy. Like if you go to any place for traveling, like if a student comes to a new university campus, so these are very tough times of for them when they don't know what's they travel a little bit and then they find there is a big drop in the sidewalk, or as we say, pavement, and they cannot move anymore. So that's why we thought that why not try to chalk out a route for the wheelchair users from a source to a destination. And then this problem started snowballing, and we find that this is indeed a very, very difficult problem. Actually, when we start solving a real world problem, there are so many parameters which we probably did not even know. So we didn't really even know that what awaits us, and then we learned so many things. So this experience I'll share with you. I just don't want to share with you what we did, but I want to share with you the problem, how deep the problem is, and so many approaches are needed to actually solve it, and so many hands should be joined to solve this problem. So I'll also encourage if there are new researchers to look into the problem and try to solve it together. Okay, now with this, let's start. So the talk is free will versus free wheel. You might have free will to go to some place, but is the wheel of your chair is free to support that? So there are multiple regulations. So we say regulations versus reality of spontaneous accessible navigation. So accessible navigation means navigation of wheelchair users, different places, they can access those places. So it's called accessible navigation. So it's routing and navigation mostly for wheelchair users. So I am in Miami University, Oxford, Ohio. I'll give a very brief description of the university. And I started working on this project when I was in Germany, and I have friends there who are collaborating with me. So I put the logo of University of Mannheim also, so as a collaborator. And this is the logo of Miami University. So Debangshu has already introduced me, so I'm not wasting time on this slide. I have joined, as a tenure track associate professor in the CAC department in Miami University in January 15, 2018. That's almost, more than 2.5 years. And before that, I was in IIT Roorkee for like 6-7 years. In the middle, sometime I spent in Germany, like 2 years altogether. And I did my PhD from Hong Kong Polytechnic University in 2010. And I did my MS in IIT Kharagpur in 2006. So, so just to talk a little bit about Miami University, it's not a University of Miami. Okay, everyone asks me, oh, it's in Florida. It's not in Florida. Okay, Miami University is in Ohio. So people think, oh, how come Miami University is in Ohio? Actually, the Miami, the word came from the Miami tribe who live in this area, in our area. This is like a valley, so it's called a Miami Valley tribe or Miami tribe. The area was called Miami Valley, and then multiple people, from here, European settlers came, and then the little town was formed. And the university was founded in 1809, and this makes MU the second oldest in Ohio and like 10th oldest public university in the US. And by the time Miami University was being set up, 1809, Florida was not even a part of US. It was a Spanish colony. So later, some people from the Miami Valley, they went to the Florida, and then they set up rail lines and stuff like that. And then they named those places with their favorite area, their hometown's name. And then that place became Miami. And as a tourist place, it became pretty famous. So we have multiple campuses. Our main campus in Oxford, which is a very, very small, it's a town in the middle of just cornfields. So it's pretty, it's a small town idea, but it's not very far from some big cities around. So we have some other regional campuses in nearby small towns. And also we have Doliboa European Center in Luxembourg in Europe. So Miami is classified as the R2 university, is a doctoral university. Some of our departments have doctoral degrees like chemistry and biology, but not all of them. High research activity. It is affiliated with the University System of Ohio. So just to give you an idea where we are located, Oxford is this one, is Oxford, and we are very close to two big cities. You might have heard Cincinnati, and Cincinnati is like 50 minutes drive from here, downtown Cincinnati, and Dayton, which is the birthplace of aviation. The Wright brothers were from Dayton. So this is like 1 hour, 5 minutes drive. So together, if from Dayton to Cincinnati, if you travel through Oxford, it will take like 2 hours, but nobody in their right mind will do that. They just take the Interstate 75. That's a different issue altogether. Miami University is very well known for its liberal arts education. So it offers more than 120 undergraduate degree programs and 60 graduate degree programs in their 8 schools and colleges. And the US News and World Report ranked Miami University as 96th among national universities. So when I joined 2 years ago, Miami University was like 73 in US. And now because of this lot of COVID and right before that, our ranking slipped a little bit. But MU is ranked 3rd best national university for undergraduate teaching, okay, 2nd among the public institution. It's also known as one of the 8 original public Ivy schools. So let me show you some photos of our campus. It's one of the most beautiful campus in US, it said. So this is our logo on the flowers and the building. And this is our campus on the fall. It's a beautiful campus. So some fall photos. This is our building, engineering building. It's called Benton Hall, and I'm sitting probably in this room here now. And this is our library. It's called King Library. There's also some photos of our fall photos of our campus. And this is some of the other buildings during the snow. So we get a lot of snow. Anyway, so now let's start the main topic of the day. And let's discuss what I have got to say. So United Nations agenda on sustainable development, which was proposed in 2015, is saying it's a 2030 agenda for sustainable development, because United Nations set up some goals that, okay, we want to achieve these things by 2030. And it was adopted by all United Nations member states in 2015. It provides a shared blueprint of the ideas how the world can be a better place, okay? How we can support all different groups of people. We can help them to prosper. We can help the countries to prosper. So it's an urgent call for action by all countries, developed and developing both, okay, in a global partnership. So we have total 17 sustainable goals. And they look like this, like 1 is no poverty, 2 is 0 hunger, good health and well-being, quality education, gender equality, clean water, and all this thing, different thing. So even life below water, life on land, so everything they are considered. I want to focus on mainly 2 goals, which is number 10, which is reduced inequalities, and number 11, sustainable cities and communities. Okay. So the UN Sustainable Development Goal 10, we call it as SDG 10. So what does it say? It says the problem it addresses is inequality within and among countries. It says that the inequality is always there, okay, within and among countries. And the objective is to reduce the inequalities and ensuring that no one is left behind. So this is very important, you know. So because I was telling this story, I just want to add that in my family, we have 2 kids, not my own kids, in my very close family, that they cannot walk or talk or move at all. So that also, you know, kind of urges me to look into the situation, that why people in India, if some person is in on wheelchair, it's very difficult for them to go out of home, because the paths and all this are not really suitable for their traveling. So that means there's inequality between people. So the target 10.2 of the SDG 10 says by 2030, empower and promote the social, economic, and political inclusion of all, irrespective of age, sex, disability, race, ethnicity, origin, religion, economic, or other status. But for my focus is the disability, so I've highlighted it. So let's see what the SDG 11 says. UN Sustainable Development Goal 11 says the world is becoming increasingly urbanized. Okay, the problem is that we know that the world is becoming very much urbanized. Everyone wants to move from rural areas to cities, and that kind of strains the infrastructure in the cities. Okay, the cities and metropolitan areas are contributing largely to the economic growth of a country. So like 60% of the global GDP, the cities are contributing. However, they because of this, you know, factories and all this, they are creating a lot of carbon emissions. So 70% of the global carbon emissions are from those cities, and over 60% of resource use. Okay, so rural areas do not have much of resources. Most of the resources are in the cities, and most of the resource usage is also in the cities. And we can also see that because of the high growth of population, the infrastructure in the cities are also very much strained. So the objective 11.2 under goal 11 is that by 2030, provide access to safe, affordable, accessible, and sustainable transport systems for all, with special attention to the needs of women, children, persons with disabilities, and older persons. Okay, so our focus is mainly the PWDs. We call PWDs the persons with disabilities. So in the disability world, the word saying disability or disabled is very, very insulting. So we have to say person with disabilities. It says the person first. So the most important people is the person, not their disability. Now we address them as persons with disabilities. So by 2030, provide universal access to safe, inclusive, and accessible green and public spaces, in particular for women and children, older persons, and persons with disabilities. So as I told you before, that this development goals are focused for both the developed and the developing countries. So like as in US, in Europe, and also in India and China, everywhere these goals, they targeted to meet these goals. I'm not saying that by 2030 everything will magically change, but as I am trying to say that United Nations identified these areas, and then they say that equality should be removed. Every person, persons with disabilities and persons without disabilities should be able to move around the cities equally. So, let's see some of the motivations, what motivated our work. We went to present a paper, actually the paper on this similar topic, to New York, and we were going to the conference venue in the morning. Okay, so we sat in the Google, it was the Columbia University, so in downtown New York. So we decided from our the hotel, to how to go to the conference venue, and then it was showing us a path. And so walking, because it's like a 10 minutes walk. Then when we came to the first picture, this juncture, we see the crosswalk. After crossing the crosswalk, the path goes to a park, and the park is very high. It's on a hill, actually. So Google never said that this goes through, it was showing it's going through a park, but it's never said the park is actually, there is a 200 feet or 300 feet height difference from the lower level to the higher level. Nobody ever on a wheelchair can move through this, because there is no elevator or any slope or anything. It's just stairs. So anyone who is on a wheelchair will come here and just get stuck. There is nothing else they can do. Okay. And then When we went upstairs through the stairs, then we find there's construction going on. And this construction is it's in such a way that there is not enough width for a wheelchair to pass. We didn't know that so many things a wheelchair person need to consider, like whether we can pass through these, there is stairs or not, whether there is any whether there'll be enough width for me to pass. So this kind of questions are unanswered when we talk about Google Maps or try to find out path from one source to destination through Google Maps. Now, that's why we are saying that traveling through the New York gave us this experience that Google Maps navigation to our destination did not give accessible paths for the wheelchair users. Then what about other locations? Let's see this one. So this is in Athens, Greece, okay? You see the sidewalk. You don't really call it a sidewalk, okay? Any wheelchair cannot move there through this, okay? So this is pretty narrow. At least you should have 30-inch width from one side to another side. This is not possible. And in Europe, people do this parallel parking, so there is no way you can get on the road or go through that, and it's also dangerous to get on the road on a wheelchair. This is also, the last picture is also on Athens, which is showing the sidewalk has grass, and this is made of brick, so this is also steep, so may not be very comfortable for people on wheelchair to travel, or even impossible maybe to travel. And this kind of paths are not really shown on Google Maps. These are unknown paths. So we said that sidewalks are often not accessible for wheelchair users. So there are obstacles. The obstacles are like this one, the third picture, where it's broken, it's narrow, and there is no curb cut. That means you cannot, there should be a slope from coming down from the sidewalk to the road. There is nothing like that. Temporary obstacles are also there. Temporary obstacles are like, there is a tree, fallen tree branch, or like in our state, because of Amphan, so many trees, light posts, and all this thing fallen. So those are like temporary obstacles. Like here we stay in a college town, so at the end of the spring and the fall semester, when students sometimes leave their dorms, they dump their discarded furnitures, mattresses on the sidewalk. So the sidewalk probably on a person on a wheelchair accessed one day before, the next day they will not be able to access it. They don't even know that when they come there, they find it stuck, that there is a big mattress sitting on the sidewalk, until the garbage collectors take that away. So these are some very, very big problems. Okay, the motivation continues. We are trying to focus on accessible floor and ground surfaces, and the regulation. So it's about ADA regulation, Americans with Disability Act. Similar regulations are in many, many other countries, in Germany, in UK, in Australia. This kind of accessing places for disabled or persons with disabilities. This kind of rules are there. So it says that must be stable, firm, and slip resistant. This is very, very important. So stable and firm means you cannot move through sand, okay? You cannot move through gravels. You cannot move through mud or grass, okay? So it has to be slip resistant. So that's why like during the winter time, when there are a lot of snow in countries where there is snowfall, so we have to consider different path during the winter time, because it has to be slip resistant. So we cannot give the same path to them during summer or during winter. So the path like concrete, asphalt, tiles, or wood, and will be good, and gravel, grass are definitely not good. To provide equal opportunities and barrier-free access, so that this kind of paths create a lot of barrier. Okay, so these are some of the brick surfaces, but if you travel through them, that will, like the first one has, you can see the gaps between them are filled. So it's much easier to travel over that. The second one, the right on the top, is much more easier. It's like a tiled sidewalk. But the third one is also very similar to the first one. And the fourth one is very difficult to travel. It's like big granite slabs. And within that, you have large gaps. So they create a lot of vibration when a wheelchair users move through them. It's very, very painful to go through that. There are even more painful things we have experimented with. But all brick surfaces, this is not granite, this is brick. All brick surfaces, but not identical vibration. They produce different type of vibration, and this very heavy vibration can be dangerous to people on wheelchairs, very uncomfortable. So you see that this two, we can say, okay, they are acceptable. This one is very acceptable. The last one is very uncomfortable to travel. So some more things, some more surfaces and curbs as barriers. So they're of many varieties, but similar in multiple environments, okay? Like the first picture is in our campus, okay? This is a sidewalk, which is broken, you see, and this is not enough wide for a wheelchair user to pass through. And so the second one is in China, okay? It's very close to Shanghai, and they have this, the local city sidewalks, and this is completely broken. And this is not really a proper sidewalk. It's not raised, not elevated, and this is close to the road surface, and this is completely broken, the concrete. So here, you know, this is also in our campus, and this is generally okay. This is not broken, this is wide, but this is very slopey. We found that it's like 12-degree slope, and by the ADA regulations, American with Disabilities Act, more than 3 to 6 degrees slope is not conducive to the people on wheelchair, okay? They will have very difficulty coming up, they will have very difficulty going down, because stopping the wheelchair will be a problem, okay? So this is also in China. You see the sidewalk is perfectly fine, coming through, suddenly there is a drop, and there is no way to reach to this road. There is no curb cut, there is no you know, access ramp to come to the road surface. So how people on wheelchair will do that? So there is also specification how much height the wheelchair can drop, and this is like more than 6 inches. So like it says that like 1 to 2 inches, that still can be manageable, but 6 inches, there is a high chance that the wheelchair can topple. So this two, last two, E and F, are from Germany. It's from Dresden, okay? So nowadays I go to every city. I, you know, very minutely check the sidewalk, check, you know, I put 2 coins. This is a €1 coin, which is a smaller one, and this is a 50-cent coin. And I show you that how difficult, you know, there was a broken, this is actually a broken part on the sidewalk, and nobody using a wheelchair can pass through. See, Germany also have this kind of lot of broken sidewalk. In our town also, there are a lot of broken sidewalks where people, they move through and suddenly they will find, no, I cannot go anymore. So how does accessibility then vary from surface to surface? And without surface information, how can we generate an accessible route? Okay, the surface can be any surface, surface of the sidewalk, surface of the you know, slope, surface of the roads, or all this kind of thing. So we, unless we have those information that where it is broken, and then how can we generate an accessible route for the user? Okay, so we have one more motivation. So surface evaluation summary is that surfaces in urban environment vary a lot, okay? Some surfaces are exhausting to use, some are even impossible, okay? So some places like this time I went to ICDCN, and it was in, you know, HHI, Hindustan International, and I was going from the metro station to the hotel, and I was checking the surface like I have the habit now. Many places surface is broken, and you know, in front of the hotel, the sidewalk suddenly drops like more than 1 feet, and you have to come down, jump, and then again go up. So for wheelchair users, those are completely impossible. It's not difficult. So please don't think I'm trying to criticize anything. I'm just, as a researcher, I'm noticing surfaces everywhere, and I'm just telling you that how difficult it's for people on wheelchair to travel. So so here, these are all from Mannheim, these surfaces, okay? This is grass, and it's very difficult to move, very high friction, and sometimes if it's, you know, wet and muddy, the wheelchair wheels can, you know, get stuck for people on different weights. So weight is also important factor for the user who is sitting there. What is their weight? So another thing is this gravel, okay? So this is also in a place where this is more like a, you know, park, and where multiple people comes in the evening. So there is it's a very big area. This is Mannheim too. All of them are Mannheim in Germany. And this gravel, you cannot move to the wheelchair. We checked many surfaces, and we find gravel, sand. These are the worst type of surfaces through which a wheelchair can, because this is not stable, this is not firm. When you move through it, it's kind of depressed and go down, so that you don't get enough friction to move forward. And then this is the most difficult surface. This is a granite squared stones with them big gaps, and it's very painful to move through them, and it's slippery also. Okay, the wheel slips because this is a granite stone. This is a sidewalk, newly made sidewalk, over which you can see the right side is a tram line. Okay, they have the city trams, and so this sidewalk is extremely useful, very good surface for wheelchair movement. And you see they have not kept a difference with the road, so that the wheelchair users can easily cross the road, seeing everything is fine or not. And the sidewalk is very wide, so it's like 5 wheelchairs can go together. Okay, so then what will be better? The better thing will be to consider surface conditions for accessible routing decisions. And the goal is to create a roadmap that allows to make routing decisions based on accessibility. So first we identify which surfaces are accessible. Then we create a roadmap asking that, okay, so these are the accessible surfaces. Then when we create a route, create the route through the accessible surface. So we need to create a bank of accessible surfaces for all the cities in the world, every place under the sun. Now you try to see that how difficult the problem is, okay, creating a bank. So as I said, the goal is to create a roadmap that allows to make a routing decisions based on accessibility. But the difficulty, as I pointed out, surface information are typically not known. Okay, so nobody actually collected surface information. This part is broken, this part is not good. This is the vibration here. Excuse me. So gathering this information is costly, subjective, prone to be out of date, and not scalable. Costly means, as I said, you have to move through, like I have moved through many places on foot, pushing a wheelchair, and then I collected the surface data using the mobile phones, the accelerometer, gyroscope, and GPS. Okay, so gathering this information is costly, and it's subjective because it depends on many parameters, like the type of phone you are using, the quality of the accelerometer data will change. Then the type of wheelchair, the type of person, their weight, their gender, if they have any disease. If a person is an athlete and using a wheelchair, there will be much more better movement than a person whose upper limbs are not very active. Their pushing will be very difficult. So it's very subjective, depends on person to person. So there's a prone to be out of date. So there's a chance that the data you collected, tomorrow there is a broken tree or a broken sidewalk, and the data becomes out of date. We have to make sure the data is always updated. So it's not scalable. You cannot really do this thing continuously. One person collecting data for the whole world, it's not possible. So it's not scalable practically. So then I talk about a little bit of the state of the art in this area. I'm not going to discuss all the papers and everything. It's impossible or not needed. What I'm trying to show that the research started in early 2000, and the initial stage, it was like GIS or GPS based system. So using some kind of global positioning satellites or information systems, what we do, we create the collect information about the surfaces, and then using a web-based system, tell user, okay, these are the good surfaces and you can move through them. So it's a GIS-based navigation device. So and then the idea of crowdsourcing came into play, where multiple people, whoever moving through the surfaces, those people are contributing data, and those data are being stored in one place, and it can be updated. Crowdsourcing's one thing is that I went on a surface 1 year earlier, and then somebody went 1 year later, they can update that data. And if we see there's changes, we replace the old data with the new data. So there are some research on inertial sensors, which started sometime from 2014 onwards. Inertial sensors are all this accelerometer and gyroscope sensors, which will record the vibration pattern when the user is moving through the surfaces. Now here also, if you calculate or collect the data using a mobile phone, there is a chance that the phone user will not drive the wheelchair with the mobile phone in his hand. Okay, mostly the mobile phone will be in the pocket or different positions. And we have experimented that depending on the position of the wheelchair, on the position on the wheelchair, the mobile phone's vibration patterns are different. Like if it is closer to the ground, the vibration is always much higher. If it is higher on the the hand support and all this, then the vibration is lower. If it's even higher near the headrest, it's the vibration is much lower than near the wheel. So it's very subjective with the position based and stuff. So inertial sensors. And then the last one is the machine learning based system, which is like this is like our system where we said that we collect data using inertial sensors. And so we try to put phones in 3 different locations in the chair, and then collect those data and study through them and find out that the most generic one which represents the vibration more normally. And then checked with machine learning, we classified different surfaces and identified which one is accessible and which one is not accessible. So but that's still subjective. So the research timeline is here. So here I tell you some of the works. I will not go into discussing all of them. I just want to discuss that some of the works are mobile friendly. Okay, the users nowadays, everyone uses a mobile phone, either Android or iPhone, and has to be mobile friendly. The earlier devices, they have this GIS based system. They are mostly web based, and modern ones are more mobile friendly. Minimal additional tool. For the GIS based system, sometimes they need separate GPS receiver or GIS receiver, and nowadays they are more inbuilt GPS sensing, or they do not use GIS system. Turn by turn navigation is a very, very important thing. The users, we should divide a whole path into multiple smaller segments and tell the user, okay, this segment is this slope, this surface, and this much, deviation or stuff like that, information, different parameters for individual road segments. So that is not given by many of the works. Automated surface classification, nobody does. We did for the first time the automated surface classification. I'll talk about it. Crowdsourced data, many works have done crowdsourcing, as I said, to update the data more frequently. And validation by subjective and objective data, like using real users to test that system and presenting those information, are not done by many people. They did probably some simulation and stuff, but real data collection and testing has not been done by any of the works. Okay, so here, what are the challenges then? The challenges is building a path knowledge base. Okay, so as I said, collecting information from the whole world and creating a bank of surface type information is not easy thing. Okay, so collecting accessibility or inaccessibility data, path features in a central large scale repository is very, very difficult thing. So now we're determining the accessibility of surfaces. We have to do it very rapidly. So suppose we have identified some surfaces, classified them, and then the user is moving to a different city, different surface, and then we get those information and immediately classify based on our training data and tell the user, okay, these are the surface types. It's not easy, and it takes a lot of resources and time. Here to make sure it's rapid. Okay, so transferring knowledge about accessible features in multiple domains. So this is one important thing, that because the variations of different parameters, so it's very difficult to transfer knowledge. So let me give you an example. Let me go to the next slide, and I'll be much easier to give you an example. Like I said, there are mainly 3 dimensions of the work. Okay, so one is the type of user. And under the type of user, there are different parameters. Like some people have some kind of disease which makes their travel difficult, like some spinal cord injuries, amputation, cerebral palsy, muscular dystrophy, Parkinson's disease, and so many things. Their age is important. What is the age? And based on, if it's less than 20, maybe they are much more strong than the people who are more than 60. Okay, So the weight, the user's weight in pounds is also important. Lighter weight users probably will have much more easy pushing, but I do not want to generalize anything. If the user has some kind of disease, then it will be difficult for them to move through. The height of the user, the gender of the user, strength or level of activeness. If it's a sporty person, can do maybe much more than a person who is not that sporty. The purpose, the user might need to go to a place, hospital, maybe it's an urgent, travel, or to a university for classes. So non-urgent, maybe you're going to grocery store. Type of wheelchair is also important. In the type of wheelchair, trust me, I didn't even know that there are so many parameters associated with the wheelchair when we started the work. So the type is like manual, power, or power assist, okay? So materials, what kind of materials, different types of wheels, okay? Like spoke and make the pneumatic wheels, solid and flat free tires. So different types of wheels are there, and based on that, the vibrations patterns change. So number of wheel pairs, sometimes they have a caster wheel, some of the power wheelchairs at the back side, sometimes at the front side, they have two small wheels. So sometimes they have 2 pairs, sometimes they have 3 pairs, depending on that vibration will change. Though it's a front wheel drive, mid wheel drive, rear wheel drive, everything will change based on that. Seat to floor height, weight capacity, how much the wheelchair can support, seat width in inches, overall width of the wheelchair. So many parameters. Then we have the environment type. Is it a natural area like forests, mountains, caves, national parks? We have the built environment, have the stairs, stairs with and without ramp, curb with and without ramp, the slope, different types of slopes. Then pedestrian crossing with traffic signal, pedestrian crossing without traffic signal, presence of elevator, and many things. The path width. So weather condition is another important thing. I already told you. If it's snowy and if it's sunny, the paths should be different, the vibrations should be different, the experience should be different. So that's what I am trying to tell. If you make all possible combinations, it is becoming an extremely difficult problem. If I collect data for a particular user with a particular disease type, age, weight, height, gender, strength, and purpose, I may not, this data, this route may not be applicable to the another user with a different types of disease, age, weight, height. So if we try to personalize, it's not easy. I mean, I'm trying to say probably the same thing again and again, just to explain you the idea why it's such a difficult problem than just showing what we did. So, and similarly, you see the type of wheelchair, if we change, we tested a lot with 4, 5 different manual wheelchairs. Then we buy a power wheelchair and we see that, oh, power wheelchair's vibration pattern is completely different than that of manual wheelchair. But then what we do with all the data we collected with manual wheelchair, can we not use them for experience of power wheelchair? Then we thought, okay, why not have an idea of how we can transfer the knowledge we collected using manual wheelchair research for 2 years to power wheelchair as well. So we are trying to check some technologies and some kind of deep machine learning approaches, transfer learning approaches, to see whether this knowledge transfer can happen. If you do not have a knowledge transfer, it's impossible to achieve this for all the places on the earth. So, but we want to have a system which will be as close to reality as possible. And so our main focus is here, the built environment. Probably the natural areas we'll think later. It's already so difficult. We want to focus on one thing at a time. So this is like this, exactly what I said in the previous slide. This is in the 3 dimensions we said. And if they are orthogonal to each other, if we pick one, one set of parameters from one and another set of parameter in the other, the third set of parameter, the environment will determine how the routing will be, what kind of routes the user should get. So to summarize this one, you see so every path segment in a longer path from A to B. So we divide in multiple segments depending on their accessibility feature. So it's a parts of path with identical characteristics. Okay, like I say that if I go from point A to point B, like first 200 meters is the sidewalk made of tiles. So that then we say that it's a identical characteristics. Next, maybe 300 meters is like slope, which is made of concrete and which is like 7-degree slope. So then we separate them. We separate each part, okay? Like surface type, slope, width, etc. So we say that we probably need some kind of machine learning algorithm for classifying path segments by dividing individual paths. So there can be from one place to another place, there can be multiple paths. And for each path, there can be multiple segments. You see the problem actually snowballs. And then the end-to-end route composed of multiple path segments. Okay, the path segments combine to form the end-to-end route. So routes are all possible permutations of path segment. We find all path segment, then make all possible combinations to generate valid routes. Okay, then we return multiple routes to users to choose from. Okay, routes matching user query are returned. User said A to B, I want to go. I am this kind of user. He has a profile, his disease and height and weight, everything, and the wheelchair type. And then we return one or more routes to the user. And then we try to do personalize those accessible routes, the match routes with the user capabilities or preference. As I said, the user provides their own, the capabilities, and then the routes has to be matched with that. Finally, the user picks the best route, which is the best suitable based on his or her capabilities and his or her wheelchair's capabilities. Okay, so this is the way the pyramid, from the broad multiple segments to one particular route for the user, the problem actually zeroes into the So as I said, the same parameters in our work, which is called Wheelshare, we first published in 2019. We address all of them. Okay, mobile friendly, minimal additional tool. You just need to use their own mobile phone. That's all. Turn by turn navigation, automated surface classification, crowdsourcing, and validating with subjective and objective data. We validated with multiple students of ours, but we did not really get chance to find some user who really use wheelchair on a daily basis. We found some wheelchair users like 2, but not many. Okay, so let's skip this. So our contribution is it's already 43 minutes. Maybe I'll try to quicken. We'll share the first machine learning based accessible routing and navigation system, which recommends routes for wheelchair users based on surface classification. Okay, we do sensor data contribution, then we do crowdsourcing for more data collection, and then you use machine learning. So a crowdsource technique to submit location tagged accessible information to an open source mapping platform to build the path knowledge base. So we use because Google Map, if we send this kind of path information to the Google Map, they do not really put those information on their map because the proprietary system. We use OpenStreetMap, which is an open source map for the researchers, and we can access the information about the road segments from there, and we can also populate, we can contribute data to that for other users. Finally, we apply knowledge transfer from a source domain to a target domain. Every combination of parameters in different all those 3 dimensions I shown you can create a source domain, and then the target domain will be another combination of parameters. Like source domain can be a manual wheelchair for a gentleman of a particular weight and height, and the power, and the target domain can be a power wheelchair for a lady of a certain age and weight and height. And so the different source and target domains can be set. So I'll probably not talk a lot about transfer learning, but these are the problems we are looking into, and these are the things we have actually done, some of them. But the problem is so big that we cannot address everything. This is like our system architecture. This is pretty big. You can see the left side starts from here. Step 1 is the surface specific data collection. We have multiple wheelchairs, manual and power. We attach mobile phones at different height and collect information about surface vibrations. And those information are, also, every user can do data collection or routing or both. So at this, when I'm moving from point A to point B, I can collect data, and I can also contribute that data to the central database. And also, if I go to a new place, I need to find a route from A to B. And when I got a route for myself, I can travel that route, and also that time I can collect data and contribute that data for other users. So at the same time, I can collect data and get the routing. So so here the user first registers. Okay, before you collect data, you register and select some operation, what you want to do, routing or data collection. And then step 1, then this is step 2. This data is contributed to the server, the starting location, ending location, sensor data and stuff like that. And then the step 2 is the surface classification. Our machine learning system classifies the surfaces based on the vibration pattern, and the classified surfaces with upload the sensor data and identified road surface. This kind of information will be uploaded to the OpenStreetMap and our own central database. So in the step 3 is this one, identify the environmental features. So all the registered users and the roads with identified surface type and the unprocessed sensor data, everything is stored there. And in the OpenStreetMap, we upload the local road network, the point of interest and the entry locations and the tagged features, all the information we do that. So and then the step 4 is real-time accessible routing. So when one user asks for route from point A to point B, we query the OpenStreetMap server and we see whether we have already our uploaded data for that segment, and then pulls those segments like the road features and POI details and the surface type, and then assign accessibility score to different features. Okay. And based on those scores, we send the user a route response. Okay, that like every different path segment in a road, we can have different score depending on it's a concrete, it's a grass, it's a gravel and stuff like that. So this is the whole thing is the server side. Then the information comes back and the user gets the accessible route response, and can choose that route, and at the same time they can also contribute some data when they travel that route. So this is the whole system, starting from step 0, step 1, step 2, step 3, and then come back step 4 and step 5. Okay, so let's skip the slides. These are actually more explanation of whatever I explained you there, the client side and the server side separately. I'm not going into too much detail into them, and I can answer questions if needed. So in summary, our approach, what it does sensor-based data collection, it does machine learning for classifying surfaces, and it takes crowdsourcing-based data for updating the information more frequently. So it's cheap because users can use their own personal phone. It's objective because it's all machine-based data collection and machine-based learning. So there is nothing manual done here. I'm not manually telling this surface is accessible, this surface is not accessible. We are classifying based on machine and then making that determination. It's scalable because if many users contribute from many different places, then even in this kind of app can be deployed in Kolkata, in any place, and then people keep contributing data. It doesn't matter what kind of surfaces are there. People can take a wheelchair and travel through that and contribute the data. These are vibration data from different surfaces. Okay, so by gyroscope and accelerometer data from different surfaces. I just give a sample to show that what kind of data we get. So how we collect the surface data. So we in the wheelchair at different height, we can see that we have put different phones, and we had a camera as a fourth phone, which was actually collecting the actual surfaces, the ground truth, video, low resolution video to show later for easier surface classification. And one phone was at the back of the wheelchair, one phone was at the side, just below the armrest, one phone was at the lower part next to the wheels. And we get those information like accelerometers and gyroscope. We also collected GPS in different cities of Europe, like Paris, Mannheim, Dresden, and Salzburg in Austria. I have traveled to collect data. Okay, so some of the surface types are shown here, how many categories to use, how to distinguish them. And so this is one thing. Let's go to the next picture, which is even bigger. So here we have this like the first few surfaces from A to like here, this one, these are all in US, okay, in our town. So here you see outdoor brick surface, which is very difficult to move, is there, sidewalk tiles, this too, asphalt, it's a running track, This is an indoor surface like a carpet. It's a indoor mat surface, indoor tiles. And these are like some soft surface. This is sidewalk, access ramp. The curb ramp is also called this for. And then this one is from Mannheim Central train station. It's an indoor surface again. It's a very smooth tiles, and this is also all in Mannheim. Different types of surface: road surface, sidewalk surface, grass. This is it's a difficult stone surface. And these are also different surfaces. And this is gravel. I already shown you this one before. These are from China. Okay, this three from here, the AA to all here in China, and this is in India. Okay, this is in New Delhi, some indoor shopping mall surface. So we collected like total, I think 32 surfaces from different parts of the world. And we also have 32 users who gave us data moving through these surfaces. And how we did the crowdsourcing around the Mannheim Central Station. I will show you that this is the Mannheim, and every multiple user contributing data, and then the road information is increasing. You will notice when I move through the slides. So you see this now around the Central Station, Mannheim Hauptbahnhof, we have some data collected, and then we move on. And you see that it grows in the size. So more people contributes data, then it grows even more. Okay, so in this way, the crowdsourcing contributed data to our system. And so now let's show you some of our results. So we have some European data, US data, we have some China data also. Here I just try to give a a high level idea of what kind of results we are getting. I'm just telling you that this is an ongoing research. Many things that need to be done. We just got maybe the tip of the iceberg, even smaller than that. So multiple different surfaces, like very smooth indoor floor, smooth asphalt floor, rough side. We just initially tell them, okay, there are total 11 surface types. Okay, then we say that, okay, what if we try to combine the indoor surfaces? Our accuracy is improved because the indoor surface has very similar vibration patterns. So we combine like rough irregular cobblestones, F, and rough regular square cobblestones. They're very similar patterns. So we do not want the machine learning system to be confused. So we combine them. We said if the first one is having some accessibility score, second one should also have similar accessibility score. And then finally we combine them even more, and we got like 5 classes among those 11 surfaces. Similar kind of thing we did for US. And we also combined this 10 different surfaces into like upward curve, downward curve, indoor surface 1, indoor surface 2. We can combine them together. Okay, upward and downward curve create same kind of vibration pattern. We say they're together. So together we get like 5 surfaces. And then we use 6 different classification algorithms, and SVM, and knife base, KNN, and all this. And based on different feature set, we had 22 different features, but we consider all the phones may not be as good. So we consider even a smaller set of features. So F1 is all 22 features, and then we gradually reduce up to F5, I think like 4 or 5 features. And we find in US data, we just tested with feature set F1 and F2. And we find that RF is the giving the best result. Is like 96% accuracy with the surface group 3, S3. So you get 96% accuracy with our classification. And these are the confusion matrices across the different classes. So the accessibility can be, let me quickly talk about the routing also. When we have, this is more like subjective, we give some scores to very smooth indoor floor, very smooth gray stone. And then based on this score, when we get different path segments, we give the scores, and then we calculate the total score, and then sort by the utility value, and then finally return the user the routing options. We also, this is in our campus map, when a user asks to go from point A to point B, we draw a circle around it and find all the routes in that circle. We do not want to go from one place to another place. We do not want to go to New York and then come back. We just want to find all the paths within that circle. This is practical, and this save the search space, or narrow the search space. what we do, we find multiple routes. This is the OpenStreetMap routing engine. And from one building, we find 2 routes to go to a different building. So this is now active and we can do that. But we have to make it, it's now only working for maybe our campus. Now we want to collect more data. Because of the COVID, from March, our data collection process completely stopped because our university did not allow to do that. That was the problem. So in summary, we collected like, here we said 26 because I think I shown 26, but we actually collected data from 32 different surfaces in the world and in different parts like Germany, Austria, France, USA, then India, China, and then 32 different users contributed their data. And at this stage, we are doing 96% accuracy. At this stage, we are experimenting with the transfer learning part. How can we transfer knowledge from one domain to another domain? This research is still ongoing. The device position helps to achieve higher classification. As I told you, where the device is placed, it's important. But we have also tested by putting the device in the pocket, because the user will most likely do that. Crowdsourcing makes data collection cheap and scalable. We design end-to-end routes. And in the next time, we are trying to include different vehicles. Like earlier, we had just a manual wheelchair. Now we have manual and power wheelchair. Later, we also want to do for strollers, rollators. We also want to do for mobility scooters for elderly people, placing phone in pocket. We have done some experiment. Clippable device. We are doing a very small, I had that device somewhere, device, which is a wearable device. People can put it somewhere. It's a very, very small, like 1-inch device, and we can clip it somewhere in the wheelchair. We also did this experiment actually. And optimize routing decisions. This is another thing. When we have more data, we can optimize the routing decisions. I'll stop here. Thank you so much. And I'll be ready for questions. And I took like 57 minutes, 53 seconds.
Okay, you are just on time. But it is the last session, so we are not in a hurry. But though maybe the listeners are a bit tired because of the whole day sessions are going on. Okay, but still we are open for the questionnaire session. So if you have any question, you can please ask, because I found the work is very interesting, and so many researchers can contribute. So it is a very big idea, and so many people should contribute then to make it a fully developed thing.
Exactly. Yeah, because people from the accessibility domain, like now because we are computer science researcher, we don't know anything about this. This is like a rehabilitation domain, but this has a lot of computer science components also. That's why nowadays all the research are cross-disciplinary. Now I understand why. Yes. So we are working with a person who is in rehabilitation in a University of Wisconsin, Milwaukee. He's a very expert in his domain. So we are now taking his advice on how to use real wheelchair users or elderly population to use our system and give us feedback. I'll be ready for any question.
Yes, but before that, I want to thank you, because I have just seen how much effort you just have put through to preparing this presentation. So it requires so many photographs and it shows that it is a hell lot of effort you have just put through behind the preparation of these slides. So thank you. And one more thing, I just seeing the streets, the paths that you have shown, most of the cases they are okay. They can be taken for wheelchair movement, but most of the cases in our city, it is that is out of question. So there is, in many cases, the sideways they are not available. And again, now the government is making some rules that all institutes and government buildings and other structures, they should have some ramp, and persons with disability, the pathway should be designed in such a way so that they can move. Earlier in say old institutes like say Jadavpur University, in many departments there is no such ramp. So it is very difficult for the persons with disability to access. Now my question is like that. So in Indian perspective, what do you feel that how much at the present scenario, how much contribution can be done from the technology side, and how much contribution should come from the rules and regulations that side, and the say infrastructure building, etc., from the governmental side, I can say. What's a sort of thing? But that means how much we are ready for in India, or especially say in Kolkata, to take up this sort of venture
Yeah.
to
So
for the
uh, let
person
me
citizen.
answer this. That what you said is completely correct. Okay, so I give you an example. Like I was in Roorkee. In our department there were stairs. Okay, so like we had two buildings, and in the middle there are, like, from one building to another building you have to take like just two steps of stairs, and then other one, so there's like a corridor in the middle. And um, I have seen there was one student who cannot walk, okay, uses wheelchair. So his parents, his friends together, they carry him, and then they take just two stairs, then carry his wheelchair also, then go to the other side of the building. This is very, very humiliating for a person, okay? So they are not child, or this is very humiliating. I feel bad. So how that person will feel when I think about it. Then later they created a stairs to elevator to go to the top floor, okay, first floor, second floor. But even when you're entering the building, we had two small stairs. Nobody on a wheelchair can enter that. So every time these things, when you see that, we every day we see, we think so normal, but when we actually see a person on a wheelchair, how they're struggling, then you realize, oh, I can walk, probably it's not that difficult for me, but what about them who cannot walk? So that I mean, I know that this probably will not be directly applicable to Indian context or many other countries. Why only India and China also? But what I'm trying to say, I do not just think that, okay, why somebody is not doing anything. I think our basic idea is to create a bank of information. So how much road is probably accessible? At least forget about sidewalk. People can move through the street in the wheelchair. What is the accessibility of those roads? If we can take photos, like using our system, we can take photos. If there is sudden changes, we can take photo. It's like you were going through a Google, following Google map, and suddenly someplace it says there's an event. You can add an event, or there is a police vehicle here. People always do that. They do speeding, and then it's, oh, there is a speed trap, so drive slow that place. So you can add, okay, there is something here. So once we can create such a big, large bank, and people see that, and then we say, oh my God, this place is not accessible for user. I think that will create an awareness among people. They will know that having two legs and good health and walking around is like, it's probably the God's greatest gift. We never realize it. We always complain about our life, but having a healthy life is probably the God's greatest gift. When we see a bank and we see, okay, these are the roads which are not accessible, a person on wheelchair cannot move through them, then probably we will realize it more. And then people from different domains, government will also be aware, okay, this kind of thing we need to make. Like you said, when we are in IIT, every building we did not have an access, they had to make that elevator. That was suddenly, it's like an augmented thing. They added that thing there, and like first 2 weeks the wheelchair, the elevator worked, then it stopped working, and nobody cared anymore, because probably we had only one or two people on wheelchair, and friends carried them to different places. But that's not a permanent solution. I think we are also getting conscious. When we see these things, we'll be more conscious. Like I am talking with our cities, the city council, the business, or local chamber of commerce, and telling them that I want to implement this system in this city, will you help? So everyone replied me and said that yes, we want to do that. What we need to do, you just tell. Probably that kind of response you will not get in India, because we are not there yet. Because to implement such a system, we need already a lot of accessibility features. Here we have those features. We are telling we will make them, the people on wheelchair can see those features. But in India, we have to make those features first. Then we have to, that's why if we can create a bank of images, bank of surfaces, and then tell the the corresponding government, I don't think they will be ignorant about that. Then when they see that, okay, what's there out, then they will be more, sensible or more,
Yes.
yeah, passionate about doing something.
And in the long term, we can have a system like just nowadays we can see in the Google Maps which road has a congestion and other rate things, because
Exactly.
that is the same thing. Same way, different users of the Google Map, they contribute to the information map. Okay, so in that
Exactly.
way, this system in a larger size volume that can contribute more.
Yeah, that's
So
our end goal, actually, to create an alternate accessible routing platform.
yes,
So
yes,
that's
yes,
our
yes.
end goal.
Yes. So, any other question from the audience? This is a very interesting topic, and so many people can contribute. So many of people from different discipline can contribute. So, please ask any question if you want to ask.
Maybe it's a little bit different topic than they are hearing for the whole day. So
Sir, I have one question.
Yes, one question. Yes, please go ahead.
Uh, Sir, actually, you have collected different images of surfaces, right?
mhm,
Yeah. And also, you have collected the accelerometer data or gyroscope data. That is, when a wheelchair is moving, there if
mhm.
the surface is uneven, then accelerometer data may change. A signal you are acquiring. How you are classifying those surfaces, whether from images or those accelerometer data.
Yeah, so that the vibration patterns, we we study the vibration patterns from this, and from here, like when we start the wheelchair, there is a little bit of movement. We are cutting those the edges of this data as noises, and then the intermediate, the middle part, we are sampling in smaller parts, and then we are taking out a lot of features, like 22 different features of them, and then we are matching the features based on that. We are trying to then classify based on our where is our, yeah, that we have labeled data, like we know what is a very smooth indoor floors data look like, and what is the rough tile sidewalk look like. Then there is a chance that the features will match for very smooth indoor floor, and probably some other thing, like here consider here this is E, rough irregular cobblestone, and this is also E. So we see that the features of these two surfaces match. So the results are not coming very good. Then we say, then why not combine these two, because these are similar type of feature. If a person can move through one, then the other also they can move through. So then we combine them, and then finally we get this result. So here we want to say that see, this is the final, the 5 classes and the confusion matrix. And what I want to tell is that later what we do for individual those classes, we add those, the accessibility scores. We say that very smooth gray tones, gray stone style sidewalk, it's 0.9 out of 1. That means if it's the maximum accessibility is 1, then it is accessible to 0.9. So when all the surfaces of the same category will have similar kind of accessibility. So that's the idea. I mean, it's a very simple, classification algorithm where based on the features, we classify the surfaces. They are already labeled, and we try to see that what is there, the percentage of match, you can say like that in very layman's term.
Okay.
Does it
Thank you,
answer
sir.
your question?
Yes, sir. Yes, sir. Thank you, sir.
Mhm.
So, if any other questions? If not, then we have come to the end of this session. And so I'd like to thank the speaker giving us the time and just delivering this wonderful lecture. And it is I'm just telling my scholars to just look into the presentation, how to place it, how to just place the presentation. It is not directly going into the data and other things. How to place the one research problem. That is the thing you can learn from this very nice presentation of Professor Rai Chaudhuri. So thank you. It is now it is all the virtual conferences. So token of appreciation from our side. Okay, I would like to share this. Okay,
Nice,
so
Rajneesh.
I can just, okay, that is a very small token of appreciation from our side. Probably that is visible. Is that visible?
Yeah. Oh, it's so
Okay.
nice. Thank you so
Okay.
much.
Okay. So thank you for giving us this opportunity to interact with you, and thank you. So now we can end up this session, and with a thank to all the participants present here. We will join tomorrow's session. Tomorrow will be there will be another keynote speech that will be at 12 noon. So we'll be joining 15 minutes earlier. So I'd like to request all the participants to join at tomorrow's lecture session at 11:45. Okay, so thank you.
Thank you, everyone. Thank you. Have a nice and healthy life.
Thank you. Thank you, Varsha. Okay. So we are ending up this meeting for now. Goodbye. Good night. Stay healthy and stay safe.